Baltimore Community Land Trust, the Community of Curtis Bay Association. He's a key contributor from the community side and co-author on all of our work. And then we've got members of our team here in person, Bonnie, Salmerón, and Laura Schmidt, who also been really great contributing. And I wonder perhaps if Matty Aubourg is online. He might be. He's also another key contributor.
And Chris, I'm on.
Great. Thanks, Greg. Awesome.
Yep. Hey, everybody.
I'm going to do like a handoff. I'll telegraph to hand it off. And Greg does have one piece of content he might share. Is he able to grab the screen share to share content if we want to have? Okay.
It looks like it's enabled. Yeah.
Good. Okay, so we'll just go over the background, give the lay of the land. Where is Curtis Bay? What's going on in South Baltimore? Why is air pollution monitoring and statistical analytic approaches, why are they important for that community context? We'll share a little bit about some of the methods that we've become aware of that might have utility given the community identified concerns that we've heard. And then we'll present some results of how we've been trying to implement some of these statistical analytic approaches. And then we'll just open it up for questions. We'd love to get feedback. We would really love if people are interested in just giving like critical feedback, like, have you thought of this? Or, this might be an issue or a concern, given some of the data analysis framework that we're standing up. So that's the overall agenda. And I'll just launch right into it. Maybe the first part, we'll give a little bit of background about South Baltimore air quality concerns and the monitoring network, but I'll hand it off to Greg, maybe just to give a little bit of that perspective about the cumulative nature of the impacts in South Baltimore. Is that okay, Greg?
Sure. Yeah, I'll be brief so we can get into it. But so Curtis Bay is a community in far South Baltimore. It's the last of what used to be 4 neighborhoods clustered together. The other 3 were involuntarily displaced by the early 2000s, mid 2000s, due to the overwhelming concentration of polluting industry, where ultimately residents were forced to leave. You're seeing an aerial drone shot of Curtis Bay, which is to the right, the residential heart of the community, and you can see it's flanked by 2, you can't necessarily see, but it's flanked by 2 diesel truck routes that move through the heart of the community with about 200 trucks per hour moving through. That's where the community's rec center is and where most of residents in Curtis Bay live. And then just to the left, closer to the water, are a large warehouse, logistics for big box retail stores, and a host of other things. And then just beyond that is the CSX coal terminal, which has been a decades-long primary source of concern for exposure to hazardous coal dust. And you see the rail lines.
We lost Greg. Greg, are you there? I think we lost your audio. Okay, maybe I'll pick up for Greg. It's just pointing out the diverse nature of both diesel truck traffic surrounding the community. This warehouse facility doesn't have a full kind of business occupier yet. It was initially going to be sort of one of these Amazon fulfillment warehouses where there'd be a fair amount of diesel truck traffic that would be coming in and out. And in addition to already what's going through the diesel truck routes that Greg's mentioning of Curtis and Pennington here and Curtis Avenue. And then you've got the coal terminal, which we'll be focusing on more in depth today. But really the picture all the way down to South Baltimore with the landfill, the Baltimore City landfill in Hopkins Point, the coal-fired power plant part of the South, Grace Chemical right here, the largest emitter of toxic air pollution, actually the largest emitter of toxic substances in the city of Baltimore by water air permits. And just generally cumulative impacts story. So for this, and let's see, Greg, if anytime your audio works again, happy to have you hop back in, but this is a picture of just on the air permits regulated by the Maryland Department of the Environment. There are approximately 70 regulated sources in Curtis Bay and South Baltimore, indicated by each of these red dots. So the aerial image we were just looking at was we were looking down from the north-south into the Curtis Bay community with the coal terminal here and the residential community just to the west. Okay. Here's a sort of from the ground view of the coal terminal and some of its infrastructure and the size and the magnitude of the piles. We'll have one more view of that as well. It just looks like Greg lost internet, so he's probably going to be trying to come back on here in a second. Pollutants that are regulated include nitrogen oxides, volatile organic compounds, particulate matter, black carbon, ammonia, and heavy metals. It's just a truncated list. But these are among the pollutants. In 2021, actually, right around the time that we're at now, the holidays, people were, December 30th taking off, they're with family, getting ready to celebrate the new year. There was a massive explosion of the Curtis Bay CSX coal terminal, which shook the foundations of the neighborhood. It was actually registered. People across the harbor in Fells Point could feel it. Earthquake scientists said it registered in terms of the seismograph activity because of the way that it exploded. The tunnels underneath the facility, which convey the coal, filled up with methane. Coal produces and off-gases a certain amount of methane, and that combined with the airborne coal particles and some of the infrastructure, which was not to code in terms of preventing electrical sparks, led to the air inside of the underground tunnel structure combusting the air, and it forced coal dust out into the community. And it's one of the instances where the industry, the coal operator itself, has admitted that they released coal dust into the community, quantified it, and the community was successful in arguing and ultimately winning a class action lawsuit for about $1.75 million as a result of that event. In addition to that, and this is a picture of a car that we saw when we were speaking with residents after the event, and just the level of black dust that you see I survived the coal pier explosion in Curtis Bay. So there's a lot of community interest around the coal terminal, just because of, as Greg mentioned, the proximity to the neighborhood, places where people live, play, playgrounds here. It gives a sense of the height of these coal piles, proximal to a rec center. And it's been something that people have been outspoken about for decades. The operating permit is on 5-year cycles for the coal terminal. And with the community testimony about the accumulation of dark dust, over these 5-year cycles, very little has changed in the operating permit of the terminal. Up until recently, since we've gotten involved and tried to make some collaborative approaches and contributing scientific information, it's led to some fence line monitoring, other things. But this is a facility that's just been in operation for decades in the backdrop of the community concerns with the dark dust accumulation. So the question is about the accumulation of dark dust on the homes, playgrounds, and schools. The testimony is that it's frequent, it could be episodic, and it's this fugitive dark dust events. And the community and ourselves and our team together have happened to be outside looking up and have a cell phone or another means of documenting things by video, and have been able to document short events between 1 minute or less than a minute to 5 minutes. And also, Greg, as a part of doing an interview with a documentarian who happened to have a drone on site, during the interview on camera behind Greg at that warehouse, there was a black plume of what looked like smoke. They thought there was a fire, but it turned out that the documentarian was able to fly a drone up and take pictures, and it was a bulldozer at the coal terminal moving and cleaning the railroad tracks free from the dust that had accumulated, and it created this large plume, which on the film that they were documenting was roughly 30 to 45 minutes. And so the big questions are, and the first one we've been able to answer is simply from a presence absence standpoint, which is a disputed claim of the industry, is there evidence that there is coal dust in the community at a time when there's not an explosion? And so we just recently were able to publish this work, which laid out double-sided sticky tape that whatever's in the air will settle onto it. And we did this for 3 days and allowed the particles in the air to settle on it. And then we can answer in those particles, which include the dark dust that the community's been complaining about and raising concerns about for decades, do we have evidence of coal particulates in that dust? And so that's what we found, is that from a presence-absence standpoint, that is true, that after 3 days, we can find evidence of coal dust, both at the fence line, less than a quarter of a mile, and also up to 3/4 of a mile away at the site of the major high school where residents are going to school. So that's that. But for today, the next questions beyond presence absence, as you can imagine, is if you're a resident of South Baltimore, what is the frequency of these events? How often are coal dust air masses making their way into the community? What's the magnitude or intensity of these, and the duration as well of these events? And what kinds of analyses could be completed that could get at some causal concepts? In air pollution sciences, the classic one is using information about proximity, upwind, downwind, right? Looking at gradients of air pollutants by known sources and whether they're upwind or downwind. And also trying to identify activities at a facility of concern that could be documented in a time-resolved manner that then could be related statistically to time-resolved information about variability in an air pollutant, okay? And so for that, it's actually a nice segue. I think Greg is back because I'd like to hand it off to him to show one of the things that we're going to present as a concept to be able to document this bulldozer activity in a way that could help us understand its potential impact on changes in air quality burden. And as a framing for this, you always want to have like, what's the prior substantive knowledge? What's the strength of your prior, right, from a Bayesian perspective? And so if it's possible, Greg, to hand off to you to share, I think there's that video from the documentarian, with the drone, if you're able to do that. And I'll maybe figure out how to stop sharing here. Maybe you can just take over, Greg. I don't know if that's possible.
Yep, just pulling it up. So first, I just want to show a really brief clip from, so you can get an aerial view of the terminal. Is this working?
Oh, hang on. Yep. 1 second.
Yeah, that's working. Great.
Okay. So you should be seeing here an aerial shot. There you can see one of the bulldozers. This is the coal terminal. There you can see bulldozers.
Wait, I don't know why moving. Are people seeing it? I'm not seeing it. Hang on.
Yeah.
Helen, do you know? Are people online seeing it? That's probably good.
Yes.
Yeah.
Good. Okay, then maybe we'll just hear.
And you can hear me?
Yes, it's perfect.
Okay. All right. So, but Chris, I mean, what we're seeing.
Okay, we're good now.
Okay. Now you're all seeing. Okay. So this is just leading into the event that Chris just described. But what you're seeing here are just aerial shots of the terminal, and then you're seeing bulldozers. All right. Now, this is the particular episode. I'm going to show you a split screen in a second, but you can see this is the drone flying over, and we were at, of course, ground level and saw that plume of what we thought was smoke, a fire initially from our perspective, about 1,000 feet away. And then because we had this drone, we were able to fly it and figure out specifically what was happening. So I'll show you now what it looked like from ground level along with the drone footage simultaneously. So on the left, this is the parking lot of the Curtis Bay Rec Center where we were sitting, discussing cumulative impacts and pollution. And then we see this, what again looked like a black smoke plume from a fire at some point in the horizon. And when we flew the drone, we saw this vehicle doing some kind of track maintenance. And as Chris said, this persisted at least 30 minutes is the conservative estimate. And we were able to then compare this to the sensor data from the monitoring network to look at elevations of PM and other particulates and gases. But just want to put this in context. This is not the most extreme event that we've observed. The terminal exploded and launched lots and lots of coal dust, into the community back in late 2021. This would be other than that, this would be the most extreme event that we've documented with this amount of precision with the aerial drone photography while we had monitors up. But the steady state of the terminal is we experience through descriptions of dark dust accumulating on surfaces of homes on a daily basis where you have to clean them off more than once. And so I showed the footage of the bulldozers because the bulldozers are active, but not always active. And sometimes we're also able to catch, not as dramatic as this, but catch visible emissions, visible amounts of dust in the air from the bulldozer activity. So we're at the community level, we're kind of piecing together through lived experience and observation, kind of a continuum that ranges from just the presence of that amount of coal at that height it's uncovered to when there's train loading and unloading, because there's frequent train shipments, to when there's bulldozers active, to when there's more anomalous, but still operations of the terminal, like I'm showing you right now on the screen, to extreme events like explosions. So there's this range of exposures that are linked to different levels of activity at the terminal. Chris, is there anything? I mean, that's sort of what I am able to present. So we'll probably keep going, but
great. No, that's great. Any questions about that? It's sort of the phenomena that we're trying to develop, both an in the field measurement. I'll talk about the methods we're using to try to measure this, and then we'll get into the kind of statistical analysis approach. Okay. All right. Let me just see if I can get back to. Yep. Okay. Over here. Good. Sorry for that. Technology is amazing. It just creates some small pauses briefly. Okay. All right. So that is the kind of where the knowledge gap that we're trying to fill is about with the lived experiences of the community. The questions now, okay, there's coal dust present, which is important to not be debating that anymore in terms of the residents, sort of the disputing that the credibility of people's knowledge on the ground. But it is important if we could provide scientific answers to the magnitude, intensity, frequency, and duration of an index, if you will, an indicator. The scanning electron microscopy approach is extremely specific. You can interrogate individual particles of a known size, a 5 micrometer particle, and you can look at it and through its elemental composition and its morphology, you can say, is it coal or is it not? High specificity, but the number of person hours it takes to collect the samples in the field, it's a 3-day wait period. Then you have to take them back to the Hopkins or another university laboratory and analyze them for hours under microscope. It's not something that you can get at this coming and going. What is the temporal scale or the time scale of this potential community nuisance? So the thing that we're really leaning into here for this chapter of the story is the advancements in multi-pollutant air sensors, which on a minute-by-minute scale can make measurements of multiple air pollutants, PM of different sizes from PM1 to PM2.5, 10. And working in collaboration with the companies who designed the sensors, they developed a total suspended particles, which is about a PM40. Why PM40? Because if you go to the coal mining occupational exposure literature, the typical particle sizes of coal that can be around human beings who are inhaling coal particles could be larger particles than the typical sensors, like a purple air, which maybe you've heard of, is great for detecting elevations or changes in PM 2.5, but does very poorly for larger particles, for PM 10, and it certainly cannot do anything larger than than PM10. So this is a sensor here called the modular. We're working with the company. It also does gases, which are on the menu for them in part because these are the EPA criteria air pollutants under the Clean Air Act. The sensor technology can support reasonably accurate, reproducible measurements of carbon monoxide, NO, NO2, and O3, ozone and CO2. They're also great indicators of other kinds of air pollution-driven activities due to vehicular traffic, combustion, and diesel activity. So each of these air pollutants, including meteorological conditions of wind direction, wind speed, temperature, relative humidity, are recorded. It's actually more granular. It's sort of a 5-second time interval, but we get data at a 1-minute time-weighted average. So every minute, we can see variability, at least in these. And another sensor company focuses really on black carbon. That's the DS Tech company here. That's the main parameter that we're using for this device. And then the combination of the two is part of the story that we're going to unfold statistically. And then the air pollutant sensors can be synchronized with simple trail cameras. I don't know, in different audiences where I do this in communities, I ask how many people are hunters and a lot of hands go up. I don't know how many hunters we have in the room here, but naturalists, if you want to observe wildlife, these are very accessible now and they're not that expensive. And they can take reasonably high quality still photos day or night. They have night vision. And they can be programmed at take a picture every second. We program to be synchronized to take a still image every minute. And then we can merge the data from the air pollution monitors with the trail camera images. And it's all in kind of where we set it up. So this is the network, a 10-node network that we're able to establish. And this is the Curtis Bay to orient you, the black large hunk of cartoonish coal is the coal terminal. The most densely focused area of the network is here just to the west in the neighborhood of Curtis Bay, stretching out to 3/4 of a mile away close to Benjamin Franklin High School, where we did the settled dust characterization, down to the southern portion of the community, and then over here onto a more industrial region of the Fairfield Wagner's Point neighborhood. And we're taking advantage of, as you go from east to west, you go uphill in the community. So you have kind of a bird's eye hilltop view, and you can see down on the portion of Curtis Bay, which is along the harbor, which the coal terminals along the harbor. And you're at such an elevation point where you can see over top of the warehouse, which is if you're at ground level, like Greg showed on the split screen, you can't see the coal terminal on the other side of the warehouse because it's so tall. Okay, and it's so long north to south in the community that you really may not even know that a coal terminal's there. So the positioning of the trail camera is really strategic. This is going to be the focus of the kind of activity assignment at time resolve scale that we'll talk about. Just as a point of information, we also had a second location on the northern edge of the coal terminal, which could look down the piles, a certain number of the piles north to south. We haven't gotten into those data yet, but you could imagine kind of like a cross-validation of the bird's eye view with really proximal to the fence line and looking directly at several of the piles. Okay, any questions about that? We had, one other thing is that at 4, the orange locations, we had both the modular and the black carbon co-located. At the remaining locations, we're just getting the modular air pollutants, not the black carbon. So there'll be sort of a subsetting that'll come back up where we have the black carbon plus particulate matter to be able to do analyses with. Distances, we're talking about the entire neighborhood is pretty proximal, less than 1.5 kilometers from the center of the coal terminal to location 10 across the harbor there. And quite close at location 1, which is really our fence line, proximal along the southern edge. I mean, literally at this location, you can look and there's anybody, I don't know who does Top Golf driving ranges, there's that netting, right? But there's netting there and it's like the coal terminal is right there in front of you. Another thing I'll mention, and this is a little bit of setup of the methods, is that the triangle shapes are angle sizes for definitions of downwind versus not downwind that we're going to explore a little bit, okay? And that's just something that I think is important to set up. Okay, so from a methods time point, I think I covered this, but we're looking at a data analysis that involves 1 minute time-weighted averages. We also, as a secondary analysis, examined other time scales of 5 minute, 15 minute, and hourly time-weighted averages, and that's just informed a lot by the community experiences of these being transient ephemeral events. That the drone footage on September 5th was approaching 45 minutes. So we'll talk just a little bit, but the main focus is going to be on the 1 minute time-weighted average analysis. The sample sizes we'll show reflect the number of records that are non-missing data for each of the meteorological parameters shown here, and also the trail camera observations on that hilltop location, which we're then assigning out to each of the nodes, okay? And this is the period for the trail camera observations. It started a little bit after we got the network up and running, and I'll get to that in a minute, but in September, actually it was here, July 5th was when we got the network up and running in 2022. So sort of the winter, spring, summer planning period after the explosion, we were trying to get up and with a network and going for about a year, a little bit over a year, depending on the node. Okay, we did, and also you have to have non-missing data for each air pollutant individually, okay? So we're approaching the idea of kind of a complete case analysis concept. We're gonna talk a little bit about sensitivity analyses and with some downwind directions that we'll talk about as well. Okay, so I don't know if you might be appropriate to say data reduction, but the non-negative matrix factorization has popped up in the air pollution sciences, particularly with multiple air pollutant measurements that can be done to be answering the question about the co-occurrence of pollutants in a framework in the air pollution sciences where there's a big interest substantively on source apportionment. What is the likely source? Okay, so we're drawing upon this. I think the literature first had studies on maybe it was PMF, positive matrix factorization, and now it's non-negative matrix factorization. So I don't know how many people is this familiar? I'm just actually really curious how many people have heard of this, okay, in this audience. Can't see online hands, but yeah, okay, that's good. And so we'll talk a little bit about the complete case analysis where we're including the modular air pollutants and black carbon in a non-negative matrix factorization. The research questions we have here, through this data reduction approach, would we be able to determine whether we observe one of these factors that could be considered indicative of putative coal dust exposure? And would we observe this at each of the locations, those 4 nodes where we have black carbon and the modular pollutants? And we would define that as non-traditional black carbon co-amplification, where if you Google black carbon right now, most likely you'll hear black carbon is a component of PM 2.5. It's incredibly useful for near roadway traffic indicator, right? It has not yet been used in a way to say, not necessarily very fine particles, because what is coal dust from coal mines? It's the median of the particle size for coal dust is around, between PM 10 to PM 30 micrograms. So PM 2.5, right? You're up higher, you're larger in size than that. So we're saying that we might see elevated fine PM 2.5, elevated coarse PM 10, elevated TSP, and elevated black carbon, okay? And so that's the first research question. And as if it's affirmative for that, we would say, the next research question is, what is the magnitude and intensity of a putative coal dust factor? And what is its frequency and duration of events, where we'll define events using just mathematical thresholds. So events that are number of minutes above the mean of that putative coal dust factor, that continuous variable at each location. Or we could have a mathematical threshold that says above exceeding the mean +1, +2, +3 standard deviations, okay? So that's the first section. And then the next section that we'll get into is just, I'm not aware of actually in the air pollution literature, people pulling in Paul Allison's fixed effects regression approach. to analyze longitudinal data. And this is really ideal for repeated measures where you're studying acute or transient events. It's not applicable for, long latency cancers, chronic diseases, incident heart disease. It doesn't really work in that, but it's this transient phenomena that come and go. And it actually is quite helpful. And we've applied it in several instances where communities have been expressing concern about a nuisance related to malodors and air pollution. So in an epidemiologic study where you have participants and you're doing repeated measures of air pollution and you're asking people perhaps in a symptom diary or a malodor scoring rating diary where they're doing this morning and evening, it allows the statistical effect estimate to be made where each individual person is their own referent, their own control. So each person gets an average of exposure, an average of the dependent variable, be it malodor scores. And then the research question is about as the independent variable deviates from its mean positively or negatively, what is that individual person's scoring of, say, malodor doing, right? Going in the positive or negative direction. And it's quite helpful where the critical potential confounders are all time varying factors. But characteristics that are non-time varying or fixed cannot confound. They can be effect modifiers of the association, but they cannot be confounders of this analytic approach. So we've applied it here. I've given a couple of examples, just to Paul Allison's SAS monograph on this, and then we've applied it to transient plumes of air pollutants from industrial livestock farming operations in North Carolina, and related it to adverse impacts on respiratory health, pulmonary function. And then we also have applied it to similar air pollution transient plumes from large regional landfills and nuisance concerns of neighbors. So the research questions that we have with this are about, is air pollution burden, as measured by a minute scale, by our air pollutant sensors, is it elevated during time periods when the wind is blowing downwind from the coal terminal versus not? Seems very simple. Next research question is air pollution burden elevated during time periods when there's an observable bulldozer activity or not? And then, is there evidence of effect measure modification, or is the association between bulldozer activity and air pollution burden modified by whether or not it's a downwind or a not downwind time period? Okay. Any questions about that? Has anybody who's heard of fixed effects models by Paul Allison before? Anybody? Yeah, great. We have a question here.
Maybe I missed it, but what's research question 1 and 2?
Oh, sorry. Yep. I'll go back. Yeah, I went over that quickly. It was the non-negative matrix factorization. And here. So would there be an observable NMF factor that could be interpreted as a putative coal dust exposure indicator?
And what the other latent factors?
The others would be, like, is there a factor that's mostly characterizing local combustion, local traffic? Is there a regional air pollution factor?
Okay.
Yeah.
And you cannot do this unless you have prior knowledge about how these pollutants contribute.
That's right. That's right. So we've been working with a team of atmospheric scientists, chemists, to be able to get that substantive knowledge, to inform the factor interpretation.
And from policy viewpoint, what's so interesting about bulldozer activity? Is it something like we can tell them to stop right away, or?
That's a great question. You kind of cut to the heart of it. Yes. What's important from a policy standpoint about bulldozer activity? And Greg, feel free to chime in. But
go ahead, Chris.
No, please go ahead, Greg.
Well, yeah, it's kind of the opposite of that. There's no interest in regulating the bulldozers per se. It's the community objective is actually to have the terminal transition from coal to another material that wouldn't explode or expose. But the short of that, which is unlikely at this point, it's to require full and total enclosure of the terminal and the loading and unloading stations. So the bulldozers themselves are being observed because of their scientific value and understanding. Can you see elevated levels of exposure when the bulldozers are active versus when they're not. So I don't know if that clarifies, but the primary regulatory opportunity that's on the table here is for that the government's already indicated they're going part of the way in a draft permit is to require physical barriers be constructed. And the community is pushing for total enclosure versus just physical barriers that wouldn't include a roof, for example.
Yeah. So here's just a quick sort of a data completeness and the contemporaneous overlap of our modular air pollutants, the black carbon and the bottom and the red here, BC. And Paul Allison's approach is actually quite nimble. If you're with a panel study, if you have 100 participants, they don't have to be enrolled contemporaneously. You can enroll them in smaller enrollment waves, right? And they don't all have to be collected. So we have a lot of gaps. We don't have great overlap in all of our air pollutants, particularly when you see black carbon. Here at the bottom, at a location like this where we've got a fair amount of gaps. And so for the research question to determine whether we can identify an indicator of putative coal dust, we've got pretty substantial data gaps here. And so that's something that if we want to use a tool out of NMF in a regression modeling approach, not having to adjust for season, not having gaps in all different times a year, that's really, really helpful for us. Okay, so here I'm just highlighting to call your attention to 4 locations where we have this suite of all air pollutants to do a non-negative matrix factorization analysis approach. And just to give you a quick overview of the sample sizes across a range of the independent variables, temperature, relative humidity, wind speed. We constructed an atmospheric stability indicator, and then here's downwind of the coal terminal. We have roughly 30 to almost 40 to 50% of the 1 minute time periods. We see that it's downwind. At some, it's interesting that it's just 10 minutes, 20 minutes. So that's something else that's important. Here is our bulldozer activity. I don't think I see. Maybe here's the the N in percent of minutes. Correct that there is bulldozer activity. Is that right? Yeah, and it's observable from our hilltop. And here's just on an average day, the average number of minutes that there's visible bulldozer activity. It's almost 600 minutes at different locations, and roughly 42% of the day on any given day. So just to give you a sense of the kind of activity, the frequency of these activities that are happening adjacent to the community. Here's the kind of table 1 of the dependent variables that the modular supplies the PM1, 2.510 TSP and black carbon, comes from the DS Tech. And we have, as far as the EPA National Ambient Air Quality Criteria, we're not talking about, which is often the case in disproportionately impacted communities, we're not talking about glaring violations of the PM 2.5 standard for daily averages. For annual running averages, we're sort of just approaching at or above the annual average of 9 micrograms per cubic meter, which is the new EPA standard for PM 2.5. But this is just to sort of give you a sense that we're at or just above, but that's not the story. And whenever communities are dealing with nuisances that may come and go, there can be substantial potential adverse impacts on health and quality of life, even if there is attainment of the Clean Air Act standards. Okay, next is the results. Do we observe a factor that can be interpreted as a putative coal dust factor? And so here we explored 3, 4, 5, 6, and we did a lot of cross-validation work to answer questions about how many factors is appropriate to fit the data. But we ended up landing on the concept of 4 factors, and we see a pretty clear putative coal dust factor, which is elevations in sort of the proportion of the composition here with PM 2.5, in sort of an orangish color, PM10 and TSP all represented, and a pretty pronounced signal from black carbon, which is unusual in the dogma. Going back to, if you Google black carbon, it doesn't pop up with PM10 or TSP. And so it's not clear that there have been that many community studies that are neighboring coal terminals where a black dark particle that's larger than PM 2.5 could be creating air pollution concerns. So we do see a putative coal dust factor. And then if we look at its magnitude and intensity here across each of the locations, the mean is here comparable, but the maximum, sort of thinking about the spikes, are highest at the locations here that are closest to the coal terminal. Location 1, 2, sort of a decreasing proximity or increasing distance. And so we do see evidence of a putative coal dust factor at each of the locations. Then if we get into the concept of sort of these mathematical thresholds, you could be answering questions about what proportion of the minutes are above the mean of the putative coal dust factor at each location. And so, here again, and you could have increasing intensity thresholds going up to the mean plus 3 standard deviations. And it's, 43 to over half of the minutes at several of these locations. Up to 20 to 30% at some of the other locations. As you get to the highest thresholds, it's also interesting that closest to the coal terminal, you're seeing the highest magnitude or intensity events of greatest frequency with about 4,000 minutes. Also observable, but at a lower frequency as you get farther away from the coal terminal. Here, just that question of what's the average duration of an event, and here we're defining an event as 2 consecutive minutes. 2 or more consecutive minutes have to be exceeding these mathematical thresholds. And what's the duration? What's the length of time that 2 or more minutes are exceeding each of these mathematical thresholds? So it looks like for the lowest intensity, there could be 12 to 13-minute events, maybe 10-minute long events that are occurring for this putative indicator putative coal dust. And for the largest intensity factor, it's anywhere from 2 minutes to 6 or 7 minutes. Okay, for this indicator concept. If you look at that same event definition of 2 or more consecutive minutes, you can get not the mean but the maximum. And so the maximum for each of these is some of these events can be up to 900 minutes long for the lowest intensity threshold. And closest to the coal terminal, you see that there's 304 minute events in duration, declining again as you get with increasing distance away from the coal terminal. Okay, that was the NMF. Any questions on that before I move on? This is research questions 1 and 2.
Yeah, Chris, this is Abhi. I'm online. Sorry for not being there in person, but I have a question about the factors. So this is based on the 4 terminals which have black carbon and only restricted to time periods where you have data from all 4, right?
Correct.
So how much data is that leaving out?
All data have to be non-missing for all of the air pollutant parameters here.
Okay.
For here in the legend.
So is that because the existing NMF methods cannot work with incomplete cases?
I believe that's true. Yes, that was our understanding. You have to do a complete case analysis.
Okay, thanks, Chris.
But I don't. Yeah, I do not claim to be an expert in this. We're working with people who have applied this before.
Okay, thanks.
Okay, so next we're gonna just look at this question of whether there's a change in air pollution burden, depending on whether those minute by minute time periods are classified as downwind from the coal terminal versus not downwind. And so you can see that for each of the individual air pollutants, first going from top to bottom, it's the smallest PM going to the largest PM40. And then we've got black carbon, and then we're carrying forward this continuous variable of the putative coal dust factor from the NMF into this regression modeling and as a dependent variable. The independent variable is, again, whether or not each minute is classified as downwind or not, from the coal terminal. And so we see the beta coefficient from the fixed effects regression models indicate that it's positive, above zero, and quite precise in its confidence interval. We see it not only for the PM2.5 and coarse particles and larger particles, we also see it for PM1, which is a bit surprising to us for the very, very fine particles. And the air pollution scientists that we work with say that if you have an air pollution source whose median is PM20, it is impossible under the laws of physics to not have it have a tail down to the small particles, okay? So that's something that has been important. And this is interesting because PM1, the dogma, is really good as a regional air pollution indicator, okay? The broad region of all of Baltimore might have very similar PM1, typically. PM2.5 from purple airs have a little bit of this utility as well. As you get into PM10 and TSP, you're talking about more hyperlocal fate and transport. Those particles settle out faster. So that's something that we were surprised by, to see this downwind effect not only be observable at a substantial magnitude in the positive direction for the large particles, but also for PM1. We also see it for black carbon, and then we also see it different scaling for these NMF factors, but we see it pretty clear positive association with very precise confidence intervals for the putative coal dust factor. So that suggests that there could be elevations in air pollution burden when it's downwind from the coal terminal versus not, okay? We're adjusting for those modular pollutants, which can indicate vehicular combustion, diesel truck traffic. So we have those measured every minute, same time scale, and we can include those in these fixed effects regression models as a plausible confounding covariate, which could be driving these associations, because from the map, if you remember, the locations where we had the air monitors, there's a lot of other sources of air pollution between the air monitor and the coal terminal.
Chris,
so that's something, yeah.
I had another question. Do the p-values or the t-values, the magnitude of them, give an indication of which pollutant is being most significantly associated, and does that match what you'd expect?
Perhaps. I don't know. I think one of the things that we're just really trying to be careful about and cognizant of is that, the collinearity of these. And so we're not adjusting each of these rows of results. They're not adjusted for the other air pollutants necessarily in being presented. But we are adjusting for the gases, which could be indicators of other sources of air pollution. So that would be, I think I'll be right, we could get at that question if we were confident about, not having collinearity problems, and we were adjusting, right, for the other air pollutants shown in the table here. Right? You could interpret the p-values in that way, right?
Yeah,
But
but you're
not-
adjusting for the same set of things in all of these, right?
Correct, but except that each of the air pollutant, like PM1, is not adjusted for PM2, but covariates are
Correct, not
PM2.
adjusting among themselves. Yeah.
Yeah. So is that maybe a recommendation you might have, is to explore that a little bit further?
I'm not sure. I don't know if others have anything to say. I was just curious because I know the absolute betas may not be compared, but maybe the t values can be compared. And I see the highest one being PM2.5, lowest one being the total suspended particles. I'm wondering if that's something you would expect or not.
Yeah. No, that's a good point. I think we might expect that, but we'd have to give a little bit more thought about that. I think initially we were just wondering about kind of general direction above or below the null, precision of the effect estimate. Yeah.
Thanks.
I have a question.
Yeah, sure.
Mean of the pollutant.
Yep.
Regardless of downwind or upwind, is the mean higher than what you'd expect in eco neighborhood?
That's great. So we didn't show the stratum specific mean here. This is just the overall mean of each air pollutant. I believe we get that in the next in the next slide here. So we did look at that, just, you know, and I'll kind of walk you through what this is. This is getting at, so let me just go to the mean, because that's a nice way to set this up. Overall, all of the data, not stratified by wind direction, the mean is this top row in each of the three pairs, okay? So the mean, your question is, when it's downwind from the coal terminal, is PM 2.5 higher on average than when it's not downwind? And it is. It's about a microgram per cubic
My
meter.
question is, like maybe it's just elevated all the time, regardless of the wind direction.
No, it doesn't look like it is not. It is not zero when the wind is not blowing from the coal terminal. It is still, you see, it's, you know, it's still measurable air pollution burden in the community here, 8 versus 9 micrograms per cubic meter.
Yeah,
Yeah.
but to put it another way, like in a sense, the causal question you're asking here is how much does air pollution change whether wind is blowing towards you or not?
That's exactly right.
A question you'd probably want to ask is what would happen if we remove the coal plant?
That would be a wonderful, wonderful. He just really outlined a strong counterfactual. The question we'd like to really estimate the answer to is if what would happen, what would be the air pollution burden change if you could remove the coal plant, the coal terminal? Yeah. I don't know how to create that without a policy intervention.
Like is the variation across communities so large that you cannot just measure what's average PM.10 in typical neighborhood with other similar characteristics and compare?
Could. Then would you still go down the same question of constructing a downwind, not downwind for that more distal community, like a background reference community, or what?
Well, so if the typical US average of PM.10 is like much lower than that, it's already pretty strong evidence that the problem is contributing.
Yeah, yeah. I think where that gets into trouble, or it gets a little bit murky, is that, you know, again, from the EPA criteria air pollutant standards, the 24-hour average PM 2.5 or PM 10 are standards, and there are threshold levels the EPA says above which you're in violation.
Okay.
We don't see really glaring evidence that there is an exceedance of a Clean Air Act criteria air pollutant. So a lot of this nuisance, a lot of this burden is happening underneath an overall picture that might be, well, there's general compliance with the Clean Air Act.
And isn't the other challenge here is that, as we've said, Curtis Bay has, you know, about 70 facilities of varying scale. And so the only difference between Curtis Bay and another community isn't the presence of a coal terminal, it's the coal terminal plus lots of other things. So finding what that comparison community would not be straightforward, as I understand it.
Maybe it's coming up, but can you look at the effect of bulldozer activity?
Yes, that's exactly right. Perfect segue. So what's the effect of bulldozer activity? Okay, so here these highlighted top bolded rows are just the all 1 minute records combined, no stratification by wind direction. And it's answering the question, is there an increase in, or is there a change in air pollution burden if on each minute by minute basis there is bulldozer activity versus not, okay? So we've answered it for wind direction, downwind or not. And here we see also that there is, it's on the, in the positive direction, quite precise confidence intervals. And it does look like here, for example, for PM about 0.5 microgram per cubic meter increase, same for PM 2.5, 1.5 microgram per cubic meter increase in PM 10, whenever there is a documented observable bulldozer moving coal around the piles versus not, okay? So the next question we had, and that's true for black carbon, and that's true for our putative coal dust indicator variable concept as well, okay? The next question we had was whether, if you stratified by wind direction, what would the magnitude of that bulldozer beta do? Would it be increased, or not whenever the wind's downwind. And we do see pretty consistently that the beta is increasing whenever, and this is the bulldozer effect is the primary independent variable, right? So this is the, that overall pooled beta of 0.437 increases to 0.8 whenever it's estimated just among the 580,000 minutes whenever it's downwind, right? And whenever it's not downwind, it's lower. And that 0.437 is an effect of an average of these strata, right? So we see for each of the air pollutants, we do see this consistent rank ordered wise pattern where the downwind stratum is an elevated magnitude of the bulldozer beta, okay? And we did some P for interaction under kind of a Wald or Breslow-Day test of homogeneity. And we do see that there is statistical evidence, at least, you know, of effect measure modification or interaction. And so we do even see this going down for black carbon and for our indicator concept of a putative coal dust factor as well, okay? So that's it. I know we're at time, but that was sort of the idea that we're doing this through fixed effects. And we saw a putative coal dust factor at each location. Its magnitude and duration indicated that there was some fence line proximity patterns. We were able to apply that putative coal dust factor into the fixed effects regression modeling framework and answer questions about these kind of fate and transport mechanisms that are very typical in air pollution literature about wind direction, downwind, not downwind. And then I think it's a bit new that we're bringing into the field, both the fixed effects approach on top of a downwind, and then also a community-driven observation idea of activities at a facility of concern with the bulldozer activity. So we also saw consistent results when we went from a 1-minute time scale to 5, 15, and 60 minutes. We haven't explored beyond this just based upon the information from the community about the temporal nature of the phenomenon. So just questions. We have a conceptual model here, you know, involving a joint effect of wind direction and bulldozer activity. And we just, you know, today or moving forward, do these represent reasonable or plausible causal pathways, concepts? I'm not going to say mechanisms, but, and then I think the real issue is if we were overlooking really critical time-varying confounders or mediators that we had not considered that could be explaining. It would have to be something that, you know, every minute that we observe and can code a bulldozer activity is happening, there'd have to be something else contemporaneous to that in order to confound these Paul Allison fixed effects models. And then, yeah, just if we haven't considered any causal inference methods or frameworks, we would, you know, welcome a dialogue moving forward. Thanks so much.